Vistum Jwalantam Sarvatomukham Nrsingham Bhisanam Bhadram Murtyum Namamyam. We have discussed that phenol is orthopara orienting. The lone pair of electron of the oxygen atom of the OH group gets delocalized into the conjugate system of the phenol up in the benzene nucleus. As a result of this, it exhibits resonance. Because of this, the oxygen atom, the OH group gets oxygen atom of OH group gets positive charge. The 2 ortho position, 2 and 6 position, they get negative charge, and para position they get negative charge. So the electron density at ortho and para position are more than the meta position. Hence, electrophilic substitution take place in phenol at ortho and para position. The probability of forming the ortho derivative is more than the para derivative, because there are 2 ortho positions are there which are negative, and 1 para position is there which is negative. Now coming to second thing I have explained in my last class, due to the delocalization of the lone pair of electron of oxygen into the benzene nucleus, the carbon bond and OH group of the phenol, they get a positive character. Hence this, but in case hence this is more stable and cannot be broken by adding a halo acid or alkyl halide, any halide, anything. If you add, we cannot break this bond easily. And the cleavage of carbon oxygen bond of OH group of phenol to give a OH group is not possible. The phenol cannot contribute a OH group or OH minus ion from the phenol to produce a carbon positive charge. But if you come to alcohol, ROH, the carbon atom of alcohol is bonded to oxygen. This bond is polar because drift of electron takes place towards oxygen atom. Oxygen atom gets negative charge, carbon gets delta positive charge. The moment we add an HX, the halo acid, it produces a carbonium ion. The carbonium ion is a positive ion, so the X minus attacks the carbonium ion, it forms alkyl halide, and alcohol forms alkyl halide when treated with a halo acid undergoing nucleophilic substitution reaction, whereas phenol cannot give that. That can be explained by concept of resonance. Now we are going to think the very important factor which most often the question comes in the exam, and also in viavos people, they ask the children in their practical viavos, phenol you have a practical, you have a test for OH group, a phenolic group. There they ask, how can you test for phenol? Now blue litmus red. Then white, blue litmus red. Now because phenol is acidic. Explain phenol is acidic. So this is, we are now going to discuss phenol is acidic. So what is an acid? First let me go to explain what is an acid. What is this? Suppose you have HX is an acid. So why? Now this HX in presence of water dissociates to produce H plus ion and X minus ion. So this is called anion. So this anion is stable after giving, when acid gives H plus, donates H plus to whom? To water. So what the water forms? It forms H3O plus hydronium ion. So the acid donates a proton to water, and water forms hydronium ion and anion. So those compounds which can donate proton are called acids. What do we mean by that? That is a sentence. All right, I donate 1 lakh rupees for a social cause. That means what? When I donate that 1 lakh rupees, I am interested to give that money. After giving that money, I am happy because my money which I have saved is used for benefit of people. So I am called donation. Means I am more stable. More happier than I was when the money was with me. I was happy. but the moment I donate that money for a cause, benefit of public or benefit of people, at that time I become more happier. Means at that time I am more stable than earlier. So here exactly same thing. Concept of acid is that if a student conceives this, then he can explain very easily. So this X minus formed is stable. Why? It has attained octet. It is attained octet, hence it is stable. And if the proton will not come to as X minus, if the X minus will not have a tendency to take back the proton, then it is acid. If it has a tendency, I gave money, but I want to take benefit out of it, I will not feel the stability, I will not feel the happiness of the donation. If I give it for a purpose, to get the benefit, if I do not get the benefit, why I gave, then a question comes to my mind. Exactly, same thing happens to this. When the X minus is produced, each if is stable, then it is a correct acid. This is the strength. This is the concept. If you keep in your mind, that means phenol, what we are going to explain? Two things we will explain here. Phenol is acidic, means phenol has a tendency to donate H+. We will first explain. After donating H+, it will form the phenoxide ion. The phenoxide ion is more stable than the phenol molecule. Phenol will donate H+. After donating H+, the phenol is more stable. The phenoxide ion is more stable than phenol. So if you come to this with this concept, we will say this is phenol C6H5OH phenol. This will, in presence of water, it will donate H+. So this hydrogen atom will come here and it will come as H+. So this will produce C6H5O minus plus H3O plus. This is called phenoxide ion. We will say this phenoxide ion is more stable than phenol. Phenoxide ion is more stable than phenol. Means there is no chance for H+ to come back to O minus. This I have explained you in my last class when I was explaining you the carboxylic acids are acidic. The carboxylic acid molecule has a charge separation. It exhibits resonance. The carboxylic acid exhibits resonance and it produces a oxonium ion, and there is a charge difference in the molecule. Hence, the carboxylic acid molecule donates H+ to water and forms a carboxylate ion. In the carboxylate ion, the lone pair of electron at the oxygen atom of carboxylate ion gets delocalized, exhibiting resonance. So the carboxylate ion is more stable than the carboxylic acid. Hence, the carboxylic acids are acidic. So the acid strength of acetic acid, I have given you example, formic acid is 17.7 in 10 to the power minus 5 and acetic acid is 1.8 in 10 to the power minus 5. This way I have explained you in last class. Exactly, I am recapitulating to you those which I have taught you in my last class so that you can understand better how phenol is acidic. Now with this concept, let us come to, we'll write the resonating structures of phenol. Then we will write the resonating structures of phenoxide ion. So this is the phenol. This phenol, and here is OH group is bonded to carbon atom of benzene nucleus by sigma bond. Oxygen atom has a lone pair of electron. It gets delocalized and exhibits resonance. It exhibits the resonance. So we get here the OH oxonium character, O plus. And here is a positive negative charge at ortho position and this. Now this pair of electron comes to this position and this gets delocalized. We get another structure here for phenol H, that this OH and positive, and here is the double bond, and here is the double bond, and here is the lone pair of electron. And then again this may come to this place and this goes to ortho position. We get another structure for phenol, that we get, this is the thing happens, and we got here the double bond and lone pair of electron here, and a double bond OH group is this, and oxygen atom has a positive charge. And then this again gets delocalized. We get back a calculus structure for phenol, where the bonds have changed their position, and we got the OH group. So this is the phenol we got, the structure 1, structure 2, structure 3, resonating structures, structure 4 and structure 5, and its hybrid is this. The hybrid of phenol is this OH group, and the pair of electron got delocalized into the benzene nucleus, and this way, and because of this we got a negative charge, and negative charge, and here is a positive charge. So this is the resonance hybrid. We have the 6th structure is the resonance hybrid. So what is happening? Structure 1 and 5 are calculus structures. They contribute toward the stability of the molecule, whereas structure 2, structure 3, structure 4, there is charge separation. So because of the charge separation, it is highly energetic, and it always loses energy. So it will tendency to lose energy. How? By losing a proton. So this has a positive charge, and here is a negative charge in the benzene nucleus. In the benzene nucleus, we will have negative charge, and here is an oxygen atom as a positive charge. And what is the tendency? There is always flow of electron from hydrogen towards oxygen. That means the hydrogen atom of the OH group has also a tendency to go away. And it will be promoted by whom? By the positive charge at the opus. So this structure, then because of this, in presence of, if you take phenol, this is the phenol, we have this, gets delocalized like this, and we have the OH, and oxygen atom has a positive charge here, and all these positions are negative, and this, and in presence of water, this phenol dissociates, loses a proton. So this comes to loses a proton and forms a phenoxide ion. We get the phenoxide ion like this, O, and we get this way. So here you get negative charge, here you get negative charge, here you get negative charge, and you got back H plus. Got lost. Now you see there is no charge separation. So this explains us that the phenol has a tendency to lose proton. Those who have a tendency to lose proton, they are acidic. So phenol has a tendency to lose proton because the 5 resonating structures of phenol are reactive, and they contribute towards the property of the molecule. They are more reactive. Hence is a tendency to lose. Now the moment we write now the phenoxide ion, so what it has? The phenol has a tendency to lose H plus. So this is phenol, has a tendency to lose H plus. So let us see how the phenol will lose the H plus. The moment we add water, what is water? Oxygen atom has H, and this oxygen atom has 2 lone pairs of electron. So in presence of water, we'll have what? So this hydrogen atom will give here is this, and here this. So this comes back to this pair of electron come back to oxygen. Why? Here is a positive charge there. So hydrogen loses and comes back to this place. So we get a phenoxide ion. Now we got a phenoxide ion. The pair of electron came to this place minus, and we have the 3 alternate double bonds, and we got hydronium ion S3O plus. If you measure the dissociation constant Ka of phenol comes to this comes to 1 point. This is 1.3 into 10 to the power minus 10. This dissociation constant of phenol is 1.3 in 10 to the power minus 10. If you take the dissociation constant of phenol is 1.3 in 10 to the power minus 10, whereas the dissociation constant of, if you take acetic acid, its dissociation constant of Sk A of acetic acid comes to 1.8 into 10 to the power minus 5. So we are now going to explain two things. That means phenol is acidic. Phenol is acidic. Why phenol? That will justify now the phenol has a tendency to lose H plus. What you have to explain? After losing H plus, after losing the proton, phenoxide ion is formed. If we can explain, this is phenoxide ion. Phenoxide ion is more stable than the phenol. Phenol has a tendency to lose H plus, we explain. Now if we can justify the phenoxide ion is more stable than phenol is acidic, can be explained. So now let's form the phenoxide ion. Now we will write the resonating structure of phenoxide ion. If a molecule or ion exhibits resonance, it becomes stable. So now if we write the structure for phenoxide ion, so in this, so there is the phenoxide ion. Now O, and here are 3 unshared pair of electrons with a negative charge, and here is the 3 alternate double bond, single bond. So this will come to delocalized. This gets delocalized, and this pair of pi electron pair will come to ortho position. So this is phenoxide ion. This is the phenoxide ion. Phenoxide ion. Now we will get a resonating structure. What? It is the structure of phenol, and now the lone pair has come here, and we get oxygen O, and here is a 2 double bonds. Now then this gets delocalized to this position, and it comes to the para position. So we get the structure for phenoxide ion. H will have this structure of phenoxide ion, and here is the negative charge, and here is the double bond O. Now this negative charge will come to this place, and this will go to ortho position. So we get the structure for phenoxide ion as this is, will have this and negative charge at the ortho position and double bond oxygen, and then we'll get the structure. This will get this structure. We got this post to this position, this comes to this position, and we get back this. So these are the phenoxide ion. These are the resonating structures of phenoxide ion. So this 1, 2, 3, 4, 5. So its resonance hybrid will be what? This is the benzene nucleus, this is the oxygen atom. The lone pair of electron from the oxygen atom is getting delocalized. Delocalization starts from this place. It moves like this, moves like this, moves like this, then produces what? Here is a negative charge. So here is the negative charge. So here also negative charge, here also negative charge, here also negative. You have a negative charge. So as a whole, the whole thing is negative. Whole thing is negative. So what has happened? Phenol, this is phenol, C6H5OH, gave H plus and form what? Phenoxide ion and H plus give. The proton has come out. Now when the proton will come back, so where the proton has gone from oxygen, it will come to oxygen to search. There is no positive charge, there is no negative charge, so H plus cannot come. So then it will come to this position. When the H plus will come to this position, the negative charge will come to this position, so it cannot go there. When he will come search and come here, it will go to this position, so it is getting delocalized. Just if you take a sandal stick, you keep this, charge is localized. The moment you rotate like this, you get a ring. Now you add water, it will not be extinguished. But if this is the sandal stick, you add a drop of water, the fire will vanish. But when it is in the ring, it is moving. The moment you add water, when you add here, it is here like this. So that is called, because of delocalization, its stability is increasing, concealment is increasing. So this is the negative back protonation is prevented by the delocalization of the negative charge of the phenoxide ion. So, and there is no charge separation. Here is negative, here is negative, here is negative. So only there is no charge separation. When in a resonating structures, there is no charge separation. The negative charge is delocalized into the benzene nucleus because of resonance. Hence, the phenoxide ion is more stable than the phenol molecule. Hence, phenol gives H plus. After giving H plus, because of resonance, the back protonation is prevented. Hence, the stability phenoxide ion is relatively more stable than the phenol. Hence, phenol is acidic. This is a very important question for a student of 12th class. If the question comes from phenol, it will, for 11th students from resonance chapter, you can have this question. So now, next question, because I am not discussing property of phenol. I am explaining how resonance will explain the properties of phenol. When I will go to discuss to you to the chemistry of phenol, I will teach you much better manner about the phenol. I am just here what is the application of resonance in explaining the acid strength and basic strength of the molecules. Now I will come to the next step. By when the phenol molecule is substituted, undergoes substitution, then what will happen to this? So what will happen to acid strength and basic strength? What are the two groups? We have two groups. One is an electron releasing group and other is an electron attracting group. So then if you come to the one simple example, when we substitute, suppose you have this phenol OH, and we substitute at ortho position nitro group. Nitro group is an electron attracting group, and we will substitute at para position because this undergoes ortho-para orienting, and we can also add a OH group, nitro group at meta position by indirect method. By indirect method we can do. So this is meta-nitrophenol. This is called meta-nitrophenol. This is para-nitrophenol. And this is orthonitrophenol. And this is phenol. So what is the negative group? This is the oxygen atom. Nitro group is what? Electron releasing group. What is the tendency of the electron to come? The electron has a tendency to come here. So what is this? Now it is pulling the electron. Just means I am going in a cycle and somebody is pulling me from the front. So when I am going in cycle, I am pedaling and going. When my friend will pulling me from the front, I will go faster in the same cycle. Here also the nitro group is the electron attracting group. It will pull the electron to come. So the electron was coming itself. Now it is pulling the electron. So the delocalization process will be enhanced. If you come to this place, again there is a pull of electron because of nitro group is the electron attracting group. So it will exhibit what? Minus I effect. This will exhibit minus I effect because of nitro group. Because of minus I effect, this delocalization process will be enhanced. Here also, but here it will not be that much. It will not be that much. So if you write the dissociation constant of this comes to phenol comes to Ka. This is as I wrote you 1.3 into 10 to the power minus 10. When you come to orthonitrophenol, this is the 10. Whereas if you come to orthonitrophenol, here the Ka comes to 600 into 10 to the power minus 10. You see, almost 600 times the orthonitrophenol is more acidic than phenol because this 600 times than this. If you come to para, it is Ka, dissociation constant comes to 690 in 10 to the power minus 10. Then what is sense? The para-nitrophenol is more acidic than orthonitrophenol. Now when you come to the dissociation constant of this K, metanitrophenol, this comes to 50 into 10 to the power minus 10. Dear students, now I am giving this homework to you to explain me next class that why the orthonitrophenol, para-nitrophenol is more acidic than orthonitrophenol, why metanitrophenol is less acidic. So what is the order of acid strength? Order of acid strength is paranitrophenol is more acidic than orthonitrophenol is more acidic than metanitrophenol is more acidic than phenol. This is a homework I am giving you, and this homework you think and write the answer. And if you have any doubt, you have our comment box. In the comment box, you can write your answer. You can write, or you can have any question. You can put there. I can be explaining to you. So this is how I am not discussing the properties of phenol. I am explaining you from resonance. We are able to explain the acid strength of phenol, acid strength of compounds. Now I am going to explain you the application of resonance in explaining basic strength of the compounds. We will have the compounds, in those compounds that the properties of this phenol we will be discussing when very soon I will be start teaching you the compounds, aromatic compounds, the preparation properties of phenol, benzene, etc. There I will be discussing the properties of phenol more vividly. Just after few classes you will be having this. So go on subscribing our channel and go on liking the channel. You will be getting wonderful answers from this. Now I am going to explain basic strength of phenol, how this basic strength of compounds can be explained by concept of resonance. So how the resonance will explain us basic strength of a basis. So we have already explained you while discussing inductive effect. Ammonia is basic. Methylamine is more basic than ammonia. What is the base? A base is one which can accept a proton. According to Lowry-Bronsted theory, protonic concept. When you come to Lewis theory of acids, an acid is a compound, a substance which has the ability to donate to donate a lone pair of electron. So those compounds which can donate a lone pair of electron, they are also bases. So the compounds which donate lone pair are bases. So those compounds which donate a lone pair of electron and accept a proton are basic. So when you come to ammonia, I have explained you this already while discussing you the inductive effect. In ammonia, the nitrogen atom has a lone pair of electron, and there is always a drift of electron towards hydrogen, and because electronegativity of nitrogen is 3, hydrogen is 2.1, so nitrogen has delta negative charge. So the nitrogen atom of ammonia has a lone pair of electron in its non-bonding orbital and a negative charge. So attracts a proton. It attracts a proton and accepts a proton. How? It donates the proton pair of electron to H+, and this forms what? This forms nitrogen. This forms 3 bonds are there. Then it forms a coordinate covalent bond with whom? With hydrogen, and forms ammonium ion. Hence, this ammonia is basic. Ammonia is basic. I have explained you last class that in inductive effect, when you come to methylamine, in methylamine the nitrogen atom is bonded to a methyl group. This methyl group is what? A electron releasing group. So it causes plus I effect. So because of plus I effect of methyl group, here is a negative charge already. Why? Because there is a drift of electron towards nitrogen atom. And because of this, that means in nitrogen atom of ammonia, you will have a delta negative charge because of this displacement. Again, a delta negative charge due to what? Because of minus I effect. So the negative electron charge density at the nitrogen atom of methylamine is much more than that of ammonia. Hence, if you have a proton, if there is a proton, this nitrogen atom donates a pair of electron this and pulls. It can pull the hydrogen H+ ion more easily than ammonia does. So this also forms alkyl methyl ammonium ion. This is forms methyl ammonium ion, and by forming a coordinate covalent bond, methyl ammonium ion. Hence, this methylamine is more basic than ammonia. So if you dissociation constant of Ka, Kb, dissociation constant of ammonia comes to 1.8 in 10 to the power minus 5 dissociation constant of ammonia. But when you come to methylamine, dissociation constant here of CH3 NH2 methylamine, this comes to 7.1 into 10 to the power minus 5. 7.1 in 10 to the power minus 5. 10 to the power minus 4. Sorry, 10 to the power minus 4. It's 10 times more stronger than the methylamine. Because of what? Because of plus I effect. Now question comes, aniline. We will explain aniline is basic. We are going to explain aniline is basic. Then we will explain aniline is less basic than ammonia or methylamine. That means aromatic question may come to a second year, the 12th class student. Aromatic amines are less basic than aliphatic amines. Question may come. Or aniline is more basic than ammonia. You may have a question. Or aniline is less basic. Aniline is less basic than methylamine. Explain. 3 type of questions you may get from this. So these things we will discuss again when we will read alkylamine, and when we will read aniline, we will be discussing more vividly. But just I am explaining you the concept of resonance, how the concept of resonance helps us in explaining basic strength of amine. So next class I will be discussing to you the aromatic amines are less basic than aliphatic amines. So you subscribe the channel by pressing the bell button, and by pushing the like sign, and you will be getting the videos. When I am uploading the videos continuously, I am uploading the videos, and you will be getting the answers. And go through them, read them, and watch the video, listen it, and give importance to each word I am pronouncing and whatever I am writing on the board. And if you have any doubt, you can put a question or give any suggestion at the comment box. Thank you so much. Wait for the next class where we will discuss aniline is less basic than ammonia and less basic than alkyl amines.